Okay, you still hanging with me, Space Marine? I'm trying to cut it up so I can actually get it on here.
Squared on top with the
I'll
c
probably need a
squared
couple.
on the bottom. And the higher order
And I
terms in
mean,
the
that's the
series are
orientation
not
of
too
what this
important for
really
now.
looks like. What is this
So we
equation?
found that we can write c
Just cut
times
you
the
out,
time
make focus
component
on this
of
part,
4
because I'm sure you
momentum
were probably
like
sliding
this.
through.
The second term in the series is the familiar kinetic energy from Newtonian physics. 1/2 times mass times velocity squared. This seems to imply that all these higher order terms are new kinetic energy terms that Newton didn't know about.
Red line would be up here.
Note that because of the U over C terms in here, these terms
you're
only
looking
become
at me
noticeable at
somewhere's in here.
speeds
There's your
close
smiley
to the
face.
speed of light.
42 is right here.
So it makes sense
Got
that
him.
Newton wouldn't have known
He
about
looks
them.
like Mew.
And finally, the first term doesn't contain any velocities
and you're right
at
here
all.
now because you
So
asked
it
that
must
question,
be
and
an
we don't have any
energy
numbers
that
for
all
this right here. The
massive objects
mass,
have,
your
even
first
when they are
table
at
number
rest.
was you jumping in here, lambda.
So really,
Why?
we found that
Because
c
that's the
times
one.
the time
The one
component
number where
of
the
4
beta number
momentum
said,
gives us
oh,
an
over the
energy
Bible
term.
or field
It's
theory.
the rest mass energy,
You come out
mc
over C. That
squared,
beat
plus
timelines
several
on,
additional
well, I got no
kinetic energy
satellites in
terms.
Jupiter, and no.
In other words, energy divided by
You're
the
on a
speed of
horse.
light
Yeah,
c gives us the
at the
time
gates,
component of
inside
4
here,
momentum.
this one pulls away from this one's getting out
So we
front.
now know the formulas for the 4 components of the 4
how
momentum
you were trained
vector.
on farm.
The time component equals energy divided by the speed of light.
And we will know.
And the space
And that's why you
components
were
equal
chosen.
the Newtonian 3 momentum, mass times velocity.
Well, again,
times
you have
the
the column
factor.
of this where this is where we got, and we got you,
Also,
Karen.
since we know that the 4 velocity
we
dotted
got
with itself gives
Chad.
c squared,
Chad.
it isn't hard to calculate the 4 momentum dotted with itself. We just get m big U dotted with m big U, which is m squared times big U dot big U, which is m squared c
dealing
squared.
At not Black Ford and
we also know that
corn.
we can calculate the dot product of 4 momentum with itself using the Minkowski metric, where the time component squared gets a positive sign and the spatial components squared get negative signs.
So now that we've established this,
we already know
ones
from
and
above
zeros
that big P dot big
system.
P equals m squared c squared. And
so,
the time
what do you see
component
like
of the
with
4 momentum is
Tell me what you
energy
see when you
over
look
c,
into the ocean.
and the
right
position
now.
components
Secret.
are just the 3 momentum
I'm a card
components
flipping
multiplied
Garney
by gamma.
that can look into a crystal
Now
ball
we can
and make you
multiply
want
all
to pay me
terms by
$20.
c
Like,
squared
I
to
didn't know that was
get
civil
this.
engineering on those
Then
things.
move
Yep.
this momentum
We're
term
just
to
gonna
the
throw
other side
down
of the
some,
equation to
I
get
wanted
this.
it to be Thorough cards.
And
It's
this
not
is
hard to
Einstein's
jump
energy
to
momentum
give you
relation.
spectrums and
It
colors and
relates the
different Bernoulli
quantities of
designs
mass,
inside
energy,
here
and
that
momentum together
started
in a
changing.
single
I'll
equation.
spin this spectrum around and say
Now,
in some
one special
fancy
case
damn
of this
universe,
formula
Stan
is
Lee
for
and
stationary
Supreme
particles.
Spider-Man and
When the
Venom and the rest
non-relativistic
of them
momentum,
out there,
mass
table
times
of reeds.
velocity, is 0. In this case, the formula reduces to the famous
vector position
equation
Einstein.
E equals
you
mc
do,
squared.
see it in your work. And
Remember, this only applies for stationary particles.
Einsteinian mechanics is
Another
the way you
special
roll.
case is the
I'll
case of a
speak wind
massless
talker, and
particle.
eventually I'll figure
If
out
m
your doomsday
equals
devices.
0, the above
And I'll either
formula
learn
seems
those
to
things
imply
because
that
I might have
energy
to
is also
if it's the
0.
region on the farm and
But
you're
we know
orientated
that
way
light,
in
which
terminal
is
position.
massless, definitely carries energy, since the sun's light heats the earth.
It's
So
imaginary.
something must be wrong here. It turns out that the formula mass times 4 velocity doesn't work to get the 4 momentum of light. The reason is that the 4 velocity big U is not well defined for light-like position vectors.
We are moving it.
The proper time tau for light-like position vectors is always 0, so it doesn't make sense to take a derivative with respect to tau for a light-like position vector. And if we try to define the components of a 4 velocity vector big U for a light-like trajectory, we end up with ut equals plus or minus ux. So we get multiple solutions for what the 4 velocity components could be. So there really is not a good way to define what the 4 velocity is for light.
I'm pretty sure superposition
So let's
works.
try to come up with
Except
a different way to define
They're
what
already
the 4
on Mars. I
momentum
don't care if
is
there's a
for
base
light.
there or not, or whatever
We know that the 4
universe that is.
momentum for light
Pickle every
should be
fucking
a
Rick in
null
there.
vector with a 0 Minkowski length. And this makes sense because the light's
Well,
mass
why aren't you
is
using
0.
me correctly then, boss?
This means that the
Get on
square
it.
of the time component of 4 momentum is equal to the sums of the squares of the position components for the 4 momentum. Now, we know that the time component of form momentum is equal to energy
Things
over
move
c.
fast, buddy. Me and you.
And I'm going
here,
to
you're
write this
here.
combination of the
We
squares
are
of the
in
spatial components
a
of
sealed
momentum
facility
as
right
just big P with the subscript light
Let's
to
be cutter.
indicate the
We gotta
momentum
catch
of
him.
a
We gotta
light
catch the
beam.
momentum in here. Okay,
So for
what
light,
is the
which
light
is
going
massless,
on? The light going
the
on.
energy of light
E's and
comes
P's.
from
This is
its
what we gotta work with.
momentum,
We gotta put it
not
together.
its mass.
Somewhere's in here. In the
And if you know some quantum mechanics, you'll know that light's
so
momentum is related to
in
its
the real
frequency,
deal, like I said again.
where
Here's
higher
the saw.
frequencies
It's pushing
give
cans.
higher
We're
momentum
doing just
and
the
energy.
micro section on. Maybe there's you
So
see
we've
the
managed
X
to
boards over here
define the form
with
momentum
some
both
Q boards
for
right
massive
here
objects
and some
and
Q
massless
whatever.
objects
So maybe it
like
cuts off
light.
over here. But what's this thing?
Let's take a look at how the form
Energy?
momentum vector
Is
is
it squared,
invariant
XY?
by looking at our
And
example
having a
with
hot danger
stationary
noodle?
Einstein and the moving car.
Okay then.
We already know the form